Guys, today we're going to talk about a thing called the discriminant, right? We learned about over the past 2 days the quadratic formula. All I did was rewrite the quadratic formula. I'll give you a hint. The discriminant is inside the quadratic formula. Do you see it? Guess what it is? No? Boy, this is amazing. Come on now. There you go. The discriminant is the stuff underneath the square root. That's why I wrote it so big. Oh, boy. You guys are so funny. That's the discriminant. The discriminant equals b squared minus 4ac. Nope. Just that. And that's what a lot of people make that big mistake. They try and take the square root with it. Nope. The discriminant is just b squared minus 4ac. The discriminant is just b squared minus 4ac. That's all it is. We're going to take a minute or so and pause away from this, and we're going to just look at quadratic equations. Here we go. So here's where we're going with the discriminant. I'll give you a hint. What does the quadratic formula solve for? What does completing the square solve for? They solve for the roots, right? There are 4 different kinds of roots, like possibilities for the roots. The first one is the normal one. Now, I want you to know that these can be drawn either smiley-faced or they can be drawn frown-faced, like going upside down, right? How many times does it hit? Hits 2 times, right? Yeah. It hits 2 times. And let's just put in some numbers, right? Give me a number for the left side. Give me a number for the right side, a nice one. What's up? 4, okay? Now, these really are the result of b squared minus 4ac being a nice square rootable number. Do you understand that? Because if it weren't square rootable, then this wouldn't condense down into like it being -2 and it being 4. You'd be left with something underneath the square root which would make a random number. Do you understand that? A little bit? Kinda? Yeah? Yeah? No? Not at all? All right. No. All right, let's really have a conversation about this. This will cement it all together. Hold on one second. So we want to know how all this stuff fits in, right? How does it all fit in together? Way back in 9th grade, you learned about these curves. True or false? True. Way back in 9th grade, you also learned that these curves come from equations that look like this. True or false? During this year, you have also learned that these equations, right, have an A in the front, a B in the middle, and a C at the end. True or false? Good. And we write those numbers down, and we fill them into this formula. True or false? Good. Do you know what this formula actually does? No. You don't know what the formula actually does. We're gonna so let's just take a minute or so. Let's just take a minute or so and decide what it is. I just showed you this on the board, right? What is it? It's minus 2x minus 8. What you are doing with this formula is, in 9th grade, you would have set this thing equal to 0. You would have solved for it. It would have been like, you know, x minus 4, x plus 2. We would have sectioned it off. We would have done both like this. You don't have to take this down, by the way. We're going to subtract 2 from each side, and you get this, the following. X equals 4 and x equals -2. That's when math was fun, right? That's when it was easy. You understand what it solves for? Or not at all? These 2 numbers are where the graph hits the x-axis. It's very useful in terms of application problems. Raise your hand if anybody's in physics. In physics, they ask you all the time, when does the projectile hit the ground? Or if you're in a business class, this might model some kind of like company that you're running or working for. When are profits at zero? You know, okay? So these points right here are called the roots. We then learned about quadratic formulas, right? Haven't we been getting all these crazy numbers like square root of 4, square root of I, yeah? How do you find those? Those numbers are not factorable. Well, it turns out there's a formula that finds you the roots. That's what the quadratic formula does. Yeah? Okay? That's what these spots are, right? Let's talk about a bit of vocab. These numbers right here, how would you describe -2 and 4? They are. They're whole numbers. How I would describe them, I would say that they are real. You know what else they are? They are rational. Do you know what it means to be a rational number? No, no, no. The word rational actually means it can be made into a fraction. -2 is the same thing as -2 over 1, and 4 is the same thing as 4 over 1, right? So they're rational numbers. The last thing they're doing, the last thing we could say about them is that they are what? They are, you wouldn't have known this, they are unequal, right? They're not the same. Yeah. Now, these types of roots take place when b squared minus 4ac is greater than 0 and a perfect square. What's up? Yeah. Should put that in. We made up the -2 and 4 just to give you an idea of some numbers. The discriminant only tells you this. The discriminant only tells you what kind of roots you have. Real, rational, and unequal, right? Another you could say is that there are 2 roots. Any questions on it? John, what's up? If b squared minus 4ac is greater than 0, the stuff in this formula, right, that finds those markers, those 2 markers, this means the stuff underneath the square root is a real number. It's not imaginary. You're not going to get I, right? If it's a perfect square, then ultimately, at the end of the day, after you get done doing all of your math, you can take the square root of this number and it disappears, right? And not by disappears, I mean like, suppose b squared minus 4ac is 25, right? Then you're going to get plus or minus the square root of 25, which is going to be like plus or minus the square root of 5. And ultimately, you'll be able to like add it to whatever b was in the front. And it'll like eventually combine and condense down to just being a fraction. You do. But let me give you something to compare it to. Just hold your thoughts. You guys are asking excellent questions. Let me draw the marks down. Give me 2 irrational numbers. Any 2 you want. Go. Irrational. Think about what it means to be irrational. I like it. Square root of 3. You don't mind, Brandon, if I do negative square root 3. So one of the roots turns out to be negative square root of 3. Okay, give me another one. Give me a positive one. Go. No. That's imaginary. Just irrational. But good. I like it. You're on the right track. Chad? Yeah, we could do. Okay, if you want to be crazy. But actually, pi would be confusing. Just give me a number. Like, how about 5? Right? But you're right. It's irrational. Okay? Everybody see these? You see how there's a square root? Hold on. One second. You see how it's a square root? You see how we can't take the square root of those numbers? They're what's called irrational. Now, these 2 numbers, how do you know if you have irrational roots? Irrational. How do you know if you get 2 irrational roots? Suppose you don't want to go through the entire process of filling out the quadratic formula. You just want to know right off the bat if they're irrational or if they're rational. Here's what you do. All you do is take the discriminant b squared minus 4ac, it's got to be greater than 0, first of all, or else we would have gotten an I, and not a perfect square. If that stuff underneath the square root comes out to be a positive number and something you can't take the square root of, then you have real, irrational, unequal roots. And there's definitely 2 of them. Now that we've gone through our description, let's talk about one more. Watch. The discriminant, not the discriminant, you get some quadratic equations. They don't hit twice. What do? They hit once. They hit once. What can you tell me about, give me a number right there. What's up? 4. Okay? 4. Talk to me about 4. What kind of number is 4? Real. It's certainly a rational number. Whoops. And then here's the weird part. Okay, real, rational. And I don't know why, yeah. And it's equal, because it's equal to itself. Yep, and then there's one root. One root. And who could think of the situation? What do you think b squared minus 4ac has to be for that to take place? What do you have to have? It has to be plus or minus this particular number for you to only get one root. No? Yes. b squared minus 4ac has to equal 0 because you can't be plus or minusing anything. Ultimately, it has to just be the front of the formula and the bottom. Because if you're plus or minusing something, it's going to create 2 separate roots. You know what I mean? Okay. All right. Finally, let's do one more. One more. One more. One more. Okay. So now we got it hitting 2 places with nice numbers. 2 places with ridiculous numbers. 1 spot. Okay? 1 spot. What do you think is left over? Go. What's up? Nope, that can't be the case because the square root has to, if it's a random square rooted number, then we automatically by default get 2 of them. Right? Go. That's what I'm looking for. And it could have been anywhere. It doesn't touch. It doesn't touch. What can you tell me about these kinds of roots? There are no roots. You just can't see them. You know what that means? They're invisible. They are imaginary. Imaginary roots. Imaginary roots always come as a pair of what? They always come as a pair of, starts with a C. They always come as a pair of conjugates, which means how many of them are there? 2. There are 2 roots. And this is going to take place when b squared minus 4ac is what? That's true. But more specifically, yeah, it's less than 0. Yep. Same. All these problems still start out the same thing as the quadratic formula. Here, all I want you to do is find the discriminant. Find the discriminant. You are not finding the roots. You're just finding the discriminant. You still need to fill this out. 1, -4, 15. Tell me, what is the discriminant? b squared minus 4ac. The discriminant is b squared minus 4ac. What's the discriminant? B squared minus 4ac. What is it? The discriminant is b squared minus 4ac. What is it? ba squared minus 4ac. So let's sub in some numbers, but for b squared minus 4ac. What's b? B is -4. So we're going to do -4 squared. minus 4 times 1 times 15. And then we're going to talk about what this means. 4 squared is 16. 16 minus 60 is what? 16 minus 60? 16 minus 60 is, I think, like 44. Yeah? Good. Okay, let me take a look. I could be wrong. Let's go. So what does the discriminant equal? The discriminant equals negative 44. So what you're really telling me is that b squared minus 4ac is less than 0. If the discriminant is less than 0, what do you know about the roots? And how many of them are there? There are 2 imaginary roots. Oh, we got it. We know what we're doing today. Write that down. Your homework for tonight is literally understanding that the discriminant is this and plugging into it and finding this number. If you want to go and write down this, that will only help you for tomorrow when we really start to think about how the discriminant matters. So let me write it down. So your homework is 2 through 6. The way they mess with you in this particular class is they don't give it to you in this form. You may have to multiply in. You may have to, like, FOIL, do stuff, move stuff over. In order for you to even start plugging in B, A, and C, you have to get it in this form. Good luck.